Alright, hi guys. Welcome to day 2 of EOG Review, and tonight we're going to review functions. And functions is a major part of our Common Core Math 1 curriculum, so hopefully this is exactly what it is a review, and that this information should be at this point second nature to you. Okay, so first we're going to take a look at what is a function. And a function is something that relates an input, which is x, to an output, which is y. So x and y have different names, input and output, and domain and range we'll talk about in a second. So how do we know if a set of data is a function? So if a set of data is a function, and a set of data we call a relation, if you remember. So a relation is just a set of data. If that relation has one input for every output, it is a function. If it passes the vertical line test, it's a function. And so another way to put one input for every output is what it means is that the x values cannot repeat. Because if they do, it will not pass the vertical line test, and that set of data or that relation is not a function. So we're going to take a look at a couple other names for our x and y values. So our domain, our input, are our x values, and our range or our output are our y values. So how can we write domain and range when we're talking about a graph on the coordinate grid? So domain again is our x values. So our graph on the x-axis goes from this point, which on our coordinate grid is 1, to this point right here, which on our coordinate grid is about 4.5. So if we're going to write that domain, and again the domain are our x values using function notation, our x values are smaller than 4.5, and they include 4.5, and they're bigger than 1, and it also includes 1. We can do the same thing for our range, and again our range is our y values, so the range is how far up and down the y-axis does our function go. So again, we're going to set it up so y is less than the highest value on the range, and this is about, let's just say for argument's sake, it's about 3.25. And it's greater than everything above it, and everything above it is above this line right here, and this line is at about 1.25. So our domain, or our x values, go from this point all the way over to this point, which is 1 to about 4.5, and our range, which are our y values, the bottom of our graph is here, the top of our graph is here, and the distance from here to here, again, is about 1.25 all the way up to 3.25, and our y values are in between and including those numbers. Okay, next up with functions is function notation. So function notation, we use f of x for function notation just to differentiate between one function or another. And again, as I said in class before, this just tells us which function we're talking about. So we can't have 5 children with everybody the same name, so we have to give every function another name. So this particular function here is the function, is the function f. And f of x just means what are we going to put in for x in this equation right here. So our input is whatever we're putting in for x, and our output is what happens when we apply this function rule to our input. So we say this as f of x equals x squared. So if let's take that function, f of x equals x squared, and if I want to know what does that function equal when x equals 4, I'm just going to take out x, and I'm going to plug in 4, and f of 4 is 4 times 4, which is 16. Let's say I have another function, we'll call this one g of x, it's just a different function. And let's say the function g of x is 2x. So if I want to find g of 3, I'm going to take out x here and do 2 times 3, So g of 3 is 6. And the reason we have these as different names because they're different functions and they have different function rules. This one is 2 times x and this one is x squared. So next we're going to move on to slope. And keep in mind that slope that we learned in 6th and 7th grade is rise over run. We also call that rise over run the change in x. No, we don't. The change in y over the change in x. So the rise is the change in y, and the run is the change in x. And we can use this slope formula, which gives us the change or the difference in y over the difference in x, and it's always y over x. And if you remember from our lovely slope dude video, undefined was the most horrible curse word you could use in mathematics. So when slope dude went over the hill, a vertical line is undefined. So how would we see that as a slope? It would be a number over 0, and that is undefined. Now a 0 slope, this is 0 fun, is a horizontal line, and that is 0 over a number. And one way I remember this is that no, you can't have 0 as a denominator, but it's okay to have 0 as a numerator. And then our trusty old positive slope is going uphill, and our negative slope is going downhill. So next up are x and y intercepts. If you remember, the x-intercept from quadratics or from any of our functions for quadratic, well, exponential really didn't have any, or linear, x-intercepts is where the line or the function crosses the x-axis. So if it's on the x-axis, we have a number for x, and the y value is always 0. So we want to know what is x equal to when y equals 0. And the opposite is also true. The y-intercept is when x is 0, what is y equal to? So when x is 0, we want to know when x is 0, we want to know what y is equal to. So if we look at these points down here on the coordinate grid, this point right here at our y-intercept, the x value has to be 0, and in this case, the y value is 5. So that's our y-intercept. If we're looking on the x-axis, that means our x value has to be 0, and our first x-intercept here is at 3, 0, and our next x-intercept is at 9, 0. So y-intercepts, we have to have an x value of 0, x-intercepts, we have to have a y value of 0. And finally, slope-intercept form. So we know that y, other names for y are our input, not our input, our output, our range. Other names for x are our input, our domain. And so M, we know, stands for the slope, and we just did the slope formulas over on the bottom left of your paper. And B stands for the y-intercept, and that's where it crosses over the y-axis. So if we're trying to find the slope and the y-intercept from a pair of points, we are going to use the points 2, 4, and the point 5, 10. And we need to find the slope and the equation of the line that goes through these 2 points. So our slope, which is m, is the change in y, which is 10 minus 4, which equals 6, divided by the change or the difference in x, which is 5 minus 2, which is 3. And if we simplify that, we have a slope of 2. So now we need to find the y-intercept. We know our slope is 2, and then we can pick either of these 2 points right here to use as our x and the y. I'm going to use 2 and 4. So if we use 2 and 4, that means x equals 2 and y equals 4. So I'm going to use my slope-intercept form of y equals mx plus b. I'm going to take out y, and I'm going to plug in 4. Take out m and substitute in 2. Take out x and also substitute in 2. And when I do that, I can figure out what the y-intercept is. So what I end up with is 4 equals 4 plus b. And if I solve for b, in this case my y-intercept is 0. So the slope of the line that goes through those 2 points is y equals 2x plus 0, and I can also write that just as y equals 2x. Okay, these questions are on the back of your homework, and if you remember, here we have a mapping, and we're asking which of these data sets represents a function. So you have a couple choices here, so let's take a look at question number 1 real quick. I want to make sure that there's one input for every output. There's one x for every y, and what that means is if I write my ordered pairs, will I have any x values that repeat? So here I have 2 goes to 5, 4 goes to 3, and 4 also goes to 9. So this tells me that I'm going to have an ordered pair that's 4, 3, and I'm also going to have an ordered pair that's 4, 9. So this input of 4 has 2 outputs, and therefore this one is not a function. So you can go ahead and check the rest of them as well. Question 2, what is the range of the function? And keep in mind that range is the y values. So we're looking for the y values on this graph. And so it's everything that's above that, and what does that include? Number 3, we need to find f of 3, so we're just taking out x, and what this really means is that we're trying to find the value of f of x when f equals 3. Number 4, what's the slope of the line? Give your answer in the fraction in simplest form. Use the slope formula for that. Number 5, find the slope and find the y-intercept for this equation. And number 6, what is the range? And again, range is y when the domain is x. So what your domain is -5, 0, and 5. So you need to find f of -5. You need to find f of 0. And you need to also find f of 5. So if I plug in -5 in this function, what am I going to get? If I plug in 0 in this function, what am I going to get as an output? And if I plug 5 in this function, what am I going to get as an output? Okay, that's it for the second day of EOG review. If you have questions, please ask them in class.